does anyone have any questions about any of the content that we went over during the 2 morning sessions? Anything from the NASA Space Biology GeneLab intro, or from Lisa's introduction to JPLPP, or anything from the intro to the command line slides that anyone would want me to go over again?
So I have a question about the echo command. Could you go through that a little bit more? Because I'm not sure I'm understanding how that's used.
Yeah, if I can ask you to hang on, we'll go through it and do it all together during the intro to Unix bootcamp that we're about to get into. So I'm going to have all you guys run these commands. Back to our schedule real quick. So we are currently on schedule, which is fantastic. We just finished all of the intro lectures in the morning, broke for lunch, and we're going to get started this afternoon with logging into the NCCS SMCE system. So this is the cloud computing system that we're going to be using throughout the bootcamp to run our introductory Jupyter notebooks, and then to process the RNA sequence data that we're going to be processing throughout the bootcamp. Did anyone not receive an email from that no reply email address? Okay, so it seems like you guys all got an email, which is great. Sorry for the delay in that. Our POC ended up being out sick on Friday, so he set up all the accounts this morning, which is why that was a little delayed. But still plenty of time for us to get started with it. So when we go into the logging the NCCS system, one thing I want to point out, because we're going to log in the same way that when you guys teach this at your home institutions, that you and your students will be logging in. And so I just wanted to show you that all the instructions for that are already in the GitHub link. I'll just put this link in the chat again. And so what you'll see here is there is a subdirectory within here called NCCS SMCE Bootcamp Setup. And so if you click on that directory, you'll see instructions for setting up the bootcamp on the system. So pretty much when you guys teach this at your home institution, this link isn't active yet. I'm waiting to hear about what programs I could use for NASA to set up this calendar, but it will be by the end of the bootcamp. So what you'll first do is you'll sign up for a time slot from which you will need access to the compute resources. I do have a note here with only one educator per 3-week time slot, but this is a question on the post-bootcamp survey, and we'll get into that. We're flexible with it, and we can always ask for more funding and try to get it if you guys need it for more than 3 weeks. So we're going to get into all of that at the end of the bootcamp. The other thing that I would be needing is, before you guys teach this at your home institution, I'll be needing the same information that I requested from all of you. I'll need it for all of your students in order to set up accounts. So that's full name, a proposed username, and I just have an example here of a last name underscore first initial, unless there's another username people want to use. An email address, and then a US phone number capable of receiving SMS text messages. The reason that this is required is because for logging into NASA systems, we have multi-factor authentication. And so in order to log into your SMCE account, you're actually going to receive a text message, which we'll get into in a minute. And then basically, once you give me all this stuff, when you teach it at your home institutions, I'll work with our POCs to make sure all the accounts get set up before you guys start teaching this at your home institutions. So once all accounts are set up, like all of ours have been, we're going to go to this website, and I'm going to put this link in the chat. So I want everyone right now to open up a browser window. If you have Chrome, it would be great if you could use Chrome, but it should work in other browsers as well. So I'm going to go ahead and go to this website here. And as the instructions say here on GitHub, you're going to be prompted to type in your username and password. Both of those should be provided in the link that you were sent. Actually, I just realized I don't have mine pulled up right now. So here's where you would type in your username and then your password. And you will get prompted to put in a new password once you put in the password that they gave you with your account. And so once you put in your password, you should receive a text message with a 6-digit verification code. So go ahead and put in that code. And then once you put in that code, you should have a screen that looks like this. So we're hooking up to a cloud computing system, and in that system, you can reserve as many or as few compute resources as you're going to need. When we went through and did a practice run of this, we were pretty good with using the small server. So that's the server that I'm going to have you guys select, which should be the default. So make sure that that small server is selected and then click start. And then this can sometimes take a minute or two to connect you to the compute resources. So it's scanning all the compute resources that are under the SMCE system and looking for ones that are available to reserve for your usage. So while that's loading, I'm just going to hop back here to the GitHub real quick and just show you guys that when you go to teach this at your home institution, I have all of these instructions written out in the GitHub, including images to show you. So for instance, is selecting the small server and then clicking next. And we're going to get into this stuff once our hubs are up. Can't seem to get the code. So Joe, you're having an issue. Is it your internet? You're not receiving a text message, Joel? You can unmute your mic. Is there anyone who's had any trouble getting to this part where it's searching for compute resources? Still waiting. Yeah, me too. Rachel, you're on. Awesome. At about 60%. Yeah, let me know. It might take a little bit too. It's because we're all connecting at the same time. But it usually doesn't take longer than a few minutes to connect. And I didn't want to log in before I logged in with all of you guys so I could go through all those steps. So I might have some stuff that I want to clean up in my home directory before we get started. So I'll take care of that as soon as mine's up. So I guess while we're waiting for everyone's to load, including mine, have any of you guys who have had a chance to kind of navigate through the GitHub repository have any questions about the material that's available there?
I looked at it. I think it's wonderful. I feel like I should make all my courses in GitHub now.
Love it. Great. I'm glad to hear it.
Quick question regarding like GitHub. I've never used it before, and I was
Mhm.
wondering what other benefits does it include compared to more traditional sites like, for example, Canvas or Blackboard?
Yeah, so Canvas and Blackboard, I don't have too much experience with those, but it's kind of like a communication sharing board, not necessarily like code-based sharing. So the benefit of GitHub is it's one of the more common platforms used to share code and to also, like if you develop a program, for instance, you can put it up on your GitHub along with installation instructions for how folks can install and use your code. So this we're using for instructional purposes, which isn't probably the most common thing to use for instructional purposes. There is another version of GitHub, which I will be converting this to at some point. It's on my to-do list called Git.io, which is a little bit more user-friendly, I would say, than the standard GitHub setup. But what this is usually used for, and I'll just jump to it and show you. So we have my training. So
So as I understand it, it's kind of like a virtual instruction platform centered around coding.
Right, exactly. Yeah.
I understand. Okay.
Yeah. Yeah. So just as an example here, this is our data processing GitHub repository. Put this link in the chat for those of you who are curious. And so, for instance, Mike, who's on the call now, one of our colleagues on the data processing GeneLab, he set up this awesome segment of our data processing repository for analyzing metagenomics data. And so just navigating through here, you guys don't need to know this for the course, but just showing you the functionality of GitHub. What he had put together is he wrapped the pipeline that we use at GeneLab to process metagenomics into a SnakeMake workflow. And so within GitHub, he goes through and the workflow for how the metagenomics data are processed is specifically metagenomics data from an Illumina platform. And then he also has this workflow information, usage, and instructions. And so on this, in this GitHub repository is everything you need to be able to install the workflow to process metagenomics data sets locally. So if you have the compute resource available, you essentially would follow these instructions and be able to download all the packages which are hosted on GitHub. We'll be going through the different tabs on top of the website as well. Yeah, I'm going to go through, well, our training GitHub repository, I'm going to go through in great detail at the end of the bootcamp to make sure that all you guys are super comfortable navigating it and knowing where things are. If time permits, we can go through some of our other GeneLab GitHub repositories if you guys are curious, like the one that I just kind of showed you here. So if you guys get this thing where it's loading and it's asking you if you want to wait, you could just click keep waiting. Usually when I click that, it like instantly pulls one up. When you guys logged on, you guys should all be seeing this. Is there anyone? Finally, oh, awesome, Joel. Glad to hear it. Is there anyone, Joel, except for probably you, might not be seeing this yet. Is anyone not seeing this? What I have here up on my screen? Okay. So everyone's good. Everyone has their instances started and is seeing something that looks like this. You should see on the left-hand side here a little folder icon with one / and in it you should probably see these two directories called EFS and Lost and Found. Is there anyone who sees anything different than what's being shown? Okay, great. I also want to let folks know that if anyone gets behind, I'm going to try to keep you guys all together. Like I said, we have a bunch of buffer time mixed in. And so we will be keeping you, all of you together. And just go back to the...
I have a quick question.
Yeah.
Regarding Jupyter, I've never used this before. Are you familiar with Eclipse?
No. I don't know if any of the other instructors are.
Okay, but I'm just wondering whether this is kind of like an online SDK, basically.
Don't know what a SDK is.
Is it like a coding platform, but like completely online?
Yes and no. So this is actually an instance, so anyone could set up a Jupyter Hub. So if you have access to compute resources or if you have an account on cloud computing, you can set up your own Jupyter Hub. You can also, as Joel mentioned in the chat, you can also set up a Jupyter Hub locally. So on your own computer, you can install Jupyter. And once you do set up a Jupyter Hub, which is what you're seeing here, so this is on a system, it can be on the cloud, it can be on just like a local compute cluster. It allows you to access all of the programs installed on your compute system through a web browser, which makes it nice. So that's why I was able to give you guys a link to this Jupyter Hub that was set up particularly for this course. And everyone could access the same link, and we are now all logged into the same cloud-based system on the SMCE resources that they have reserved on an AWS instance. And so that's what we're using. Okay. Let's see. So before I get into it, just as our next break is going to come at 1:30, so I'll make sure that happens. And while we're all here, I'm going to hand this off to Lauren to help you navigate. But before I do that, I want to make sure everyone can copy and paste the content that we're going to be going through. So one more question in the chat. I see, so it can run programs that were developed through clouds. Yes. So different people on different PCs can access it. Yeah. So you can access this. Again, we have set up accounts. So this is like a private Jupyter Hub where you would need an account to access it. So that's why you guys all have to give me that information so we could set up accounts. So this is being run through our supercomputing system at Goddard, specifically SMCE, who has an AWS instance that we're running these resources on. So this is all kind of being run on the cloud. So before we get started, before I hand it off to Lauren to tell you guys more about how to navigate the Jupyter Hub, I first want to make sure that we copy all of the content that we're going to be using. So if everyone can scroll down to the bottom of this launcher that you have here in this open tab and click Terminal. And then it should bring up a terminal that looks like this. And I want you guys to run a command which is going to copy all of the content to your home directory. So in this command, similar to the instructions for logging onto the system, is all available in GitHub. So none of this stuff you guys have to write down or memorize. It's all here. So this is the step that we're on now. For those of you who are also following along the GitHub. So once your server's up, in the other section, which is where we just went, you click on the terminal icon. And then in the terminal window, I want you guys all to run this command. I'm going to put it in the chat so you can just copy and paste that command into the terminal window here. So it should look like this. And then you're going to press enter. And then once you do that, you will see, it might have a little delay, but you will see a bunch of files populate on the left-hand side panel. So you see here, I have a CSV file, a couple of text files, and then I have all of these files that end in IPYNB. So these are all of our Jupyter notebooks that we're going to be running. There's 4 in total. And so these are all stored somewhere else within the system. So the command that you just ran here is a command that I had set up to allow you to copy everything that we're going to need to run the bootcamp into your home directory. Is there anyone who was not able to run that command and see the information or see the files populated on the left panel here? Okay, cool. So everyone's with me. And then just to show you guys what this looks like in the GitHub repository, since you'll be following this along when you teach this at your home institution, I have listed in step 5. So after you copy and paste this command, you should see the following added to your home directory. So here's a list of all the files that you should have seen populated in your home directory. And then I also had put a screenshot of what that looks like. So you guys can all make sure that you are where you should be and that all your students will be where they should be when you teach this at your home institution. So that said, I'm going to pause real quick and stop sharing my screen, and I'm going to hand it off to Lauren to just give you guys an overview of the Jupyter Hub and the Jupyter Notebooks, how to navigate, what to check for, what to look for in case you get kicked off and things like that. So Lauren, if you want to take it away.
Yes. All right. Is everyone seeing the Jupyter Hub screen? All right.
Yeah, I can see yours.
Great. So first of all, I wanted to kind of, before I get into the Jupyter Hub, we've been having some questions about just Jupyter in general. And so I wanted to give just a really, really quick overview of the way I think of Jupyter and why we're using it here. So sort of starting with the evolution of how code is written and used and shared. So one way that you might have written code yourself or seen code written is just using a text interpreter. You just write a script, you name your script whatever. This is a Python script, so it's .py. You go over to a terminal, and you run some commands, and you run your script. This is great. You can get the job done. This is a really simple script. If I wanted to share this script with somebody, I could just send them this file. I've put some comments in here, so any line that starts with a hashtag is actually not executable. It's just a comment. I'm just telling you what I'm doing with that code. So it's shareable in that I can just send you this file. But there are some reproducibility issues here where you could change something in this file. You might not remember what you've changed if you're like me. And so now we have two different versions of the same file with slightly different outputs, right? So this works, it's fine. But Jupyter, the Jupyter Notebook infrastructure was developed specifically to be able to have reproducibility and shareability of code in a very readable way, a very intuitive way. So I'm showing here a completely random Jupyter Notebook. This has nothing to do with the bootcamp today, but I just wanted to show an example of, you can have little cells here that where you can just write notes. You can explain to the people coming after you what you've done. You can also have outputs like tables. You can have lots and lots of notes here that are not code. It's just explaining what you did. And you can also have visualizations. And as you can see, these are all embedded. They're embedded right into the notebook. So then if I were to send you this notebook, you'd be able to see exactly the code that I ran to get this visualization. Whereas if I have a script here and then a .png image that came from that script, they're in two different places. It's not clear that one exactly led to the other. So reproducibility was really, and shareability, those were the motivations for the Jupyter project. Now, it works out really well for us in the kind of educational field because these are turned out to be really, really great pedagogical tools. Because if you put together a notebook, you can write in before the code, you can explain what the code's going to be doing. Then you can have a code block. The students can run the code block. They can immediately see the output. It's directly connected to the code. They can change the code and see a change in the output. So as we talked about earlier, you can run notebooks locally. So like I have this is just a standalone notebook. It's in my downloads folder. And this is just local for me. I could send you this notebook. I could put it on GitHub so that you could see it there. Then after Jupyter Notebooks were developed, there was a new innovation called a Jupyter Hub, which is a place where many people can log in, like we all just did. We can all access the same notebooks and the same code. So that's what we're doing here. So this is a little different from just having a standalone notebook. We have an actual file tree that you can, this is what we call the Jupyter Hub. We have a file tree that we can all interact with and see lots of files there. So we do have 4 standalone notebooks that we're going to be running through in the workshop, and these are also the notebooks that you would use at your home institutions. And you can also see here any of the input and output files that we're going to be interacting with in these notebooks. So that's kind of the way that I see, this is a very small snippet of the evolution from standalone scripting all the way into these interactive Jupyter hubs with notebooks. So that being said, we're now in a Jupyter hub. As Amanda noted, this is not running locally, this is running on the cloud. It can interact locally, so we'll show you how you can download completed notebooks and so on and so forth. But for now, I just want to show you how to navigate the hub in case you've never used a hub before. So Amanda already showed you how you can open up the launcher by clicking the big blue plus button. So I'd like everyone to please open the launcher again. And instead of going into one of the notebooks that we'll use in a minute, I want us to just open up a new notebook so that I can show you some things. So go ahead and click on the very first, you can see you can open lots of different things, notebook, console, terminal, etc. Let's open a Python 3 notebook by clicking on that first box. So has anyone not been able to open a Python notebook? It should be called untitled.ipynb. And you should have just one little box here where you can write code or something else. Okay. All right, great. So there are a couple of things that I want you to notice here if you've never used a Jupyter Notebook before. The first one is that up in the top right-hand corner, you will see that you have a button called, it's called Python 3, and it says IPY kernel. And if you hover over it, it says switch kernel. So the kernel refers to the underlying code installation that is being accessed by this notebook. So this is a notebook that is currently running the Python language. There are different coding languages. We're going to use two different coding languages in this workshop, Python and R. And so we have two different kernels, one that has the Python language installed and one that has the R language installed. And not only are the base languages installed, but we've also installed specific packages, which are like groups of code that run specific functions that we need for the analysis we're going to do. So it's not enough to just be running Python 3. We actually need to switch the kernel to the exact kernel that we had installed with the packages that we need. So if you click up here, as I just did, it'll take you to this select kernel box, and you can select the correct kernel. So you can see start other kernel here. The two that we're going to be using in the boot camp are the Python, Conda, and GL4U. That's our Python kernel, or the R, Conda, and GL4U-R. So again, I think Amanda mentioned earlier that Conda stands for Anaconda, which is a package manager. That's how we had all of these packages installed, was just through Conda. So that's why it says Conda there. So the reason I'm showing you this is because occasionally on this Jupyter Hub, the kernel will die. For whatever reason, it becomes disconnected from your notebook. And so you may have to go up here and grab the correct kernel. So in this case, let's click on Python, Conda, and GL4U and select that kernel. So now this blank notebook should be starting to connect to this kernel. So you can check and see if your kernel was successfully connected by going down. Yes, I can do that again. So I clicked top right, where it now says Python GL4U. It might say something different for you, but I clicked here. I went to select kernel and the drop-down menu, and at the drop-down menu, I selected the Python GL4U kernel. And then I clicked select. All right, so, and I was just pointing out that you can check on kind of the health of your kernel by looking in the bottom left of your screen. I hope everyone can see this. Mine currently says Python, Conda, and GL4U idle. It sometimes says connecting or initializing. Sometimes it can say disconnected. And that might mean that you need to restart the kernel. Thank you. The Jupyter window doesn't show all the buttons if it's split screen with Cisco. Okay. That makes sense. Okay, so I've shown you how to establish a kernel in your notebook. I want to show you a couple more things for interacting with Jupyter notebooks before we actually get into a real notebook. So the first thing is this box here is it's an interpreter. You can write text here. Currently, this box is set up to receive code. And you can tell that because this drop-down box here, where if I hover over it, it says select the cell type. Right now it says code. So this is a code. We also call these boxes cells. So that's how we will be referring to them. So this cell is set up to receive Python code, but we can change the cell type. So I can change it to Markdown, and that's where I can write a note to myself, like the following cell runs code. And then I can execute this cell by hitting the what we call the play button or the run button. And I've been given automatically a new cell all set up to receive code. So we're probably going to be doing some of this in the notebooks that we'll be using in the workshop, adding cells, writing Markdown, or writing little bits of code. Now, let's say I wanted, yes, markdown is text comment, yeah. So let's say I wanted more than one empty cell here. I can add a new cell by going up to the top and clicking on the plus button. So that adds cells. And let's say I want to delete this cell. I can use the scissors to delete this cell. This action is non-reversible, and it is a great way to delete code and never be able to see it again. So please be very careful with the scissors button. All right, I think that's all I wanted to show you from these buttons up here. Oh, except for in case if you are running something that seems to be taking a long time or not working, you can hit the stop button to interrupt the kernel. That's the box there. There is no Control Z in Jupyter. I wish there were. It is very unfortunate, believe me. So we have to be very careful. Yeah, no spell check either. All right, I wanted to show also, let's see. There is one more menu I did want to make you familiar with, which is this up at the very top. You see there are some buttons here. These are all buttons that help you interact with the Jupyter Hub as a whole. To interact with the kernel of the currently selected notebook, you can go here to kernel, and you can interrupt it, which will stop any code you have running. You can restart it in case it seems to be misbehaving or it's disconnected or something. You can also restart the kernel and clear all your outputs. So if you're running through a notebook, you'll get all those outputs I was showing you. You can clear them in case you want a nice clean notebook, or you can restart and run all the cells of a notebook. All right. I think that's all that I wanted to go over. Amanda, is there anything else that you wanted to add?
I think you covered everything. Just the one thing that maybe you forgot to mention in everything that could be indicated in the bottom left for the Python conda environment GL4U, it's currently idle. So the other thing that Lauren did mention is it also could say busy. So when it's actually running a command, it'll say busy there as well.
Thank you, Amanda.
I think you covered everything. Thank you so much, Lauren. And as you guys have questions, if things aren't clear, you want to go over some of the functionalities or something again, please just stop us, unmute your mic, put a message in the chat, and we can stop and revisit anything related to the Jupyter Hub. Okay, so I am sharing my screen again. Is there anyone who cannot see my screen? Okay, great. So we are ready to get started with our first notebook. So this notebook is the Intro to Unix notebook. If you want to, you can go ahead and actually X out of the tabs that we had open. You don't need them anymore. And this course is designed assuming that the people taking it have no command line experience. And so the first couple of notebooks that we're going to be going over today and tomorrow are to get you all comfortable or at least familiar with running these commands in the Jupyter Notebook, and we'll start actually by running them in the terminal. And so again, we're not expecting you won't be able to become a coding expert in just a week and a half long boot camp, but I'm hoping that these introductory notebooks will at least give you a foundation to start with and hopefully make the command line not seem as scary. So we're all going to get started with this Unix intro JN 06-2022.ipynb. So if you guys can all double click on that file in the left-hand panel. And you should see a notebook open up that looks like what I'm showing here on my screen. Is there anyone who was not able to open up the Unix intro Jupyter notebook? It's slow? Okay. So it hasn't opened yet? Not yet. Okay. Still not opening. So I'll give it another few seconds. Hopefully everyone's will be able to open. You guys are going to be opening, if you look over to the left here, you should be opening the Unix Intro JN 06 2022. Kanisha, are you seeing that notebook in your left side panel? Just server error. Okay. Lost connection to the server. Okay. Let me talk to my POC since we're already having people's go down.
Do you want me to email him?
Yeah, Can you respond and email him to switch the instances? Thanks, Lauren.
So everyone has their own instance. So this shouldn't be an issue of, oh, we're all trying to access, the same thing at the same time. So some of you may have internet connectivity issues that have to do with the Jupyter Hub.
Open fine.
For the person who had the Dask server error, I think that means that you have to restart your entire Jupyter Lab instance
Yeah.
from the very first link that Amanda shared.
So I would hit the restart, reload your web page. That should work. Is there anyone? Like I said, we have buffer time, so I want to make sure. Okay, awesome. Got it. Now I have to restart. Is everyone who had to restart their instances, are you guys here with us now, or is anyone still waiting to open up the Unix intro? Still waiting. Okay, Ty, we'll wait. Is yours, what are you seeing here? Ty, are you seeing it's a Python environment or it's just like frozen? You can mute your mic. If it's frozen, you might want to just try refreshing your browser.
I don't know why I started to type all that. So yeah, it said that the server needed to restart, so I hit the restart button. And so
Okay.
now it looks like it's almost done restarting.
Okay. Okay, we'll give a few more minutes just to make sure everyone's is up before we actually get started with the content. While we're waiting, I'll just go over some things about the notebook. For those of you guys who haven't loaded yet, you can just view in the WebEx window that you have up. So this Jupyter notebook was built, we ran this pilot for the students for the first time last year in collaboration with San Jose State. We actually utilized their compute cluster though. So this is the first pilot that we're running on the SMCE cloud computing system. So thank you all for being our guinea pigs. Oh, good, Tigers work. Okay. So many of the foundational bioinformatics methods are going to be run through a Unix shell, including most of the RNA sequence data processing tools that we're going to be running in our first RNAseq notebook, which is called the FastQ Accounts Jupyter Notebook. And so the purpose of this introductory notebook is to just get your feet wet with some of those Unix commands that I went over in the lecture, and including the echo command, which we'll get into in this notebook a little bit more. Just so you guys can start getting comfortable running commands, seeing what they look like when they're run, seeing how you can mess up. Most of the time it's a syntax error when you mess up commands. But this is basically to get your feet wet and to just give you an overview of how to run commands both on the terminal, and then we're going to jump right into the Jupyter notebooks. So all these notebooks are set up the same way in that there's going to be a table of contents in each and every one of them. And this table of contents is interactive, so you can click and jump to various parts of the notebook. So like when we come back from breaks or things like that, and you need to jump to a certain part of the notebook, you can use the table of contents to kind of jump around the notebook. So before we get into it, is there anyone that's still waiting for their instance? Or anyone that's still waiting for the Unix Intro Jupyter Notebook to be up? That's great. So that means that all of you guys are good to go. I'm good to start running. Okay. So we're going to get right into it here, and you'll notice these notebooks, and we're going to be jumping throughout the bootcamp back and forth between these notebooks and also the lecture material. And so for the intro one, we kind of gave you all the lecture material up front. And so when we do this notebook and also our intro to our notebook, which we're going to start tomorrow, we're going to be mostly staying within the system and doing this hands-on environment. So as Lauren mentioned, the nice thing about these notebooks is we can write text here in addition to being able to run commands. So you guys can kind of follow through. A lot of this content I went over in the lecture, so they're going to be going over some more of it during the notebook to hopefully solidify the information and then running the commands. So starting with what is Unix, and Unix is an environment where we interact with the computer by typing and reading text. So similar to what I mentioned in the lecture. The computer needs the commands that you type to follow that very specific format that we went over in the lecture. So we're going to be using this language in a Unix environment for commands we send to the computer in this notebook and in the FASTQ to counts notebook when we begin processing our RNA-seq data later in the bootcamp. So in this first setup here, we're going to be running Unix commands in a simulated command line. So the most common way to run Unix commands is using a command line or a terminal, which I went over in the lecture. So we're actually going to do that first because this Jupyter Hub is equipped to be able to run terminals as well as Jupyter notebooks. And I kind of gave you a sneak peek of that when you guys ran that copy command to load all of your files into your home directories. And so to learn about running commands first on the command line or the terminal, we're going to use part of this awesome tutorial, a Unix tutorial that was written by our colleague Mike Lee, who's one of our instructors on the call. And so if you guys want to learn more about Unix, and really Mike Lee has an alias called AstroBioMike and is just phenomenal at writing introductory content and teaching non-bioinformaticists how to do bioinformatics type things. So if you want to learn more and view Mike's tutorial, I encourage you all to click on this link and learn more about it. Where were the files copied from? So I set up everything that we need for the bootcamp within this structure. So it's actually way embedded into this EFS. And actually, you kind of take a look at that command that we ran, which is right here. You'll notice that the script that we ran is located in the EFS folder and then in GL4U and RNAseq Bootcamp. And it's 2026 Educator Bootcamp, and then that's the script. And so all the files are within the directory structure within there. Oh, thank you. And so it's embedded within the system. And actually, since we're all in the same system, you guys technically can go directly to those files and make all sorts of changes to them because we're all like part of the same group. So don't do that. But if you do, I have backups of everything just in case. So it's all within this directory here, EFS. We won't get into it, but if you're really curious at the end, I'll show you where everything is exactly. And so thanks to Mike's awesome Unix tutorial, I actually copied kind of verbatim from step 1B of Mike's tutorial with some minor modifications. And I just basically copy and paste it so that way we're in this environment, whereas Mike actually has you set up another simulated terminal. But since we already had one accessible, I'm borrowing all of his stuff for the beginning of this Jupyter notebook. So like I mentioned, we're first going to start by running things in a terminal window. So the first thing that we're going to do is we're going to open up a new terminal window, similar to what we did at the start. And so first, as Lauren had went over previously, I want you to click on this blue button in the upper left corner, and this is going to open up another tab in the launcher window. And then you're going to scroll down to Other. And I do want to point out that when you teach this at your home institution, all of these directions are written explicitly in the Jupyter notebook. So you don't have to memorize anything, don't write anything down, it's all there. So you click on that blue button in the left corner, this webpage to open up a launcher window, which is what we just opened up in this new tab here. And then in the launcher window, you're going to scroll down to the Other section and click on that terminal icon. And so that's what we did way at the beginning before I explained what we were doing. So down under Other, you're going to click on Terminal. And so this should open up, similar to what we did at the start, a terminal. And hopefully we get our command prompt soon. So you should get a command prompt which looks like this. It should look something similar. And you should get a cursor flashing there. And so I'm going to be flipping back and forth between here and here. If you guys just want to stay on your terminal window and follow along with me, you can. Or if you want to flip back and forth with me, you can also do that. If you want to copy and paste things, you'll have to flip back and forth. So this window that opens is very similar to a command line or terminal that's going to be available on a computer running Linux. So a computer like or a computer running Unix, so a computer like a Linux computer or Mac. It'll look just like that when you open up a terminal window. And so we're going to run a few commands in this terminal window environment. So first we're going to learn about the syntax of commands and their arguments, as well as two important commands called date and head by following the instructions below. Again, all pulled from Mike's tutorial section, hit the section titled Running Commands. So the first command we're going to do is called date. So in the terminal window, we're going to run the date command, which is the command that prints out the date and time. And just a note here that this particular command does not actually require any arguments. So let's see what this command looks like. So I want everyone to either copy and paste or type this into the terminal window, just date. So we're going to go ahead and run date and then just press enter. So you guys should see an output when you do that in your terminal that looks similar to this. And so hopping back into the Jupyter Notebook here, when we run date with no arguments, again, no arguments meaning there's nothing that comes after the command itself. So you saw that we just ran date with no additional arguments afterwards. It uses some default settings. So it actually assumes that we want to know the time in the computer's local time zone. So I have this first question here, and we have all of our questions set up in what's called a poll. So I am going to open up my poll questions for you guys. Can you guys see a poll window that I have open, or is that just mine? Can you guys see this?
Nope.
Yeah, no, what'd you say?
No, I can't.
Oh, great. Okay, so I am going to open up a poll. Just give me a second here. Okay. Okay, so all of the questions that I prompt you in here, I'm going to actually ask you through a poll, and then you'll be able to submit your answers. So I'm going to go ahead and open this poll. And then you guys should have all seen a poll question. So if you guys can answer that poll. And I'll just wait till everyone's done answering. And so this is asking the question, what time zone is a computer system set to? And you should get that information from looking at the output of our date command in the terminal window. Let's see. So it looks like I'm still waiting for about 5 of you to hit submit on your answers. We're asking the question, what time zone is this system set to? Waiting for 3 more of you guys to answer. I need all my instructors to answer too, because I don't know who answered what. 2 more.
I didn't realize instructors were supposed to answer.
Yeah, I don't have that status of who's answering right now for some reason. You're out on a break. Looks like I have 1 more that needs to be submitted. Okay, awesome. So I'm going to close the poll. And then I'm going to bring this over here just in case nobody wants their answer shared. And it looks like most of you guys got this right. And so what you notice right here, this UTC is actually the time zone that's indicated in the command, or in the output of the date command. So that means that the system that we're running in is set to UCT, or Universal Time. That's actually also the time that the ISS is set to. And so moving on, so in addition to running this date command alone without any options, like what we just did, we can also provide optional arguments. We can also provide optional arguments to the date command. And so these optional arguments most often require putting a dash in front of them in order for the program to interpret them properly. So similar to what I went over during the lecture. And next, we're going to add one of the arguments, -R, which is going to tell date to report the time in RFC 5322 format instead of the current format that it's being displayed. And so I want you all to copy and paste this next command into the terminal window. So this is date with a space, because remember, spaces are special. It's telling the program that we're running this date command, and then -R is the option that we're running. So we can all go ahead and hit enter there, and you should see that format change to what it looks like here on my end. Is there anyone who's not seeing this output on your computers? Okay, good. And so now I want to see, let's try to play around with the command syntax. So now let's try running the same command in the terminal window, but without the dash. So we're going to copy and paste date space R without adding a dash, and then press enter. You guys should all see something that looks like that. Is there anyone not seeing that? Okay, and so you'll notice that that gives an error. I want to try one more thing before we start to dive into why this is. I want everyone to go ahead and copy and paste this next command here. So this is date-R, but this time we remove the space. So let's go ahead and run that command. And you should see something that looks like this. Is there anyone who doesn't see that? Okay, so you'll notice that that gave a different error because without the space separating date in the optional argument -R, the computer doesn't know how to break apart the command. I want you to notice the little things about the errors that we got. So the first error in this program is, from the program date, and it doesn't know what to do with the letter R. Whereas the second error is from bash, the language we're working on, because it's trying to find a program called date-R since we didn't tell it how to properly break things apart. So just looking at the terminal here, to go over that one more time. So this first command that we ran that gave an error, we didn't give a dash, but we do have a space. So you'll notice that when we got an error, what's giving us that error? What function is providing the error? You guys can type your answers in the chat. You can just take a guess. You don't know. So where did this error come from? What program? No guesses? Don't be shy. The answer is in the Jupyter notebook. Yeah, the program date, exactly. So we see that it tells us that date is giving us this error saying that it's an invalid R, meaning that the program date doesn't recognize this R that we gave it to interpret. Now when we run this command date-R again, but this time we don't put a space in, what program is giving us an error now? Yeah, bash. So bash is giving us this error, and it's because when we run this date-R without spaces, what the system is doing is it's looking for a program called date-R. So the bash Unix interpreter is looking for a program called date-R. And when it doesn't find that, bash is like, hey, we're not finding this command called date-R. And so that's how the computer recognizes spaces, whereas here it knew you were running the date command because we had a space right after date. So it was date that's saying, I don't recognize this option because we don't have a dash in front of it. And then when we ran it without the space, it's recognizing this whole thing as the command that it's supposed to look for. So bash is like, wait a second, I don't see that command anywhere in the system. So those are the two different kinds of errors that we're seeing from date and from the bash interpreter. So now let's talk a little bit about this next command called head. And so unlike date, most commands do actually require arguments and won't work without them. So head is a command that prints the first few lines of a file, so it requires us to provide the file we want to act on. So I want you to copy and paste this command in the terminal window. So this head space example.txt. So you can go ahead and paste that in your terminal and press enter. You guys should all see an output that looks like this. Is there anyone not seeing that? So date said this is invalid flag for me, and bash said this is an invalid. Yeah, exactly, Ty. That's exactly right. Is everyone seeing this from the head example.txt command? Okay, so I'm going to ask you some questions on this. So in this command, example.txt is the required argument, and in this case, it is also what's known as a positional argument. So whether things need to be provided as a positional argument or not depends on how the program that we're using was written. So sometimes we're going to need to specify the input file by putting something in front of it, like the -r that we put in front for date. And sometimes we need to specify an input, some programs that have a command where you need an option to specify an input. Some of them use like -i for input flag, but it could be something else as well. Whereas in this head command, when we did head of example.txt, we didn't need to tell it that the input file was example.txt. It just knew that it was because of the position of where it was within the command that we wrote. So I do have this question here. How many lines does the head command print by default? And I will pull up a polling question again for you guys all to answer that. So go ahead, you guys should have seen that question pop up on your window. Everyone can answer it, including instructors. A couple more of you. I guess I should put here so you can see. So how many lines does the head command print by default? Waiting on one more person. Submit. Something weird happened. I just typed head and nothing else. I got a bunch of empty lines. Yeah, the head command can't be run alone like the date command. So that's probably why. If you need to get back to your command prompt, if you hold down Control C on your keyboard, it'll bring you back to your command prompt. I'm gonna go ahead and do that. So I think I'm still waiting for one more person to answer it. I'd hit enter many times. Yeah, no problem. Anytime you need your command prompt back, pressing Control C will stop anything that's running and give you your command prompt back. I think I have one more person that still needs to answer the poll question. How many lines does the head command print by default? Make sure you hit submit on your answer. Okay, I'm going to go ahead and close the poll. Right here. Okay. So yeah, it looks like you all got it correct. And so the answer is 10. Of course, pretty easy to see. Sorry, just closing the poll. Pretty easy to see, right? When we did head example.txt, it just so happens that this file has this line is line for each line. So you'll notice that the first 10 lines were provided when we ran head on this example.txt file without any other options included. So again, you'll notice that there are also, or even though there was no flag given, that was a positional argument of the file that had to come after the head command. There are also optional arguments for the head command that we could have put in. So the default for head, as you guys all noted, is to print the first 10 lines of a file, and we can change that by specifying this -n flag followed by how many lines we want. So let's give that -n flag a try and copy and paste this command in the terminal window. Go ahead and run that command in your terminal window. And is there anyone who isn't seeing this? Okay, good. And so how would we have known that we needed the -n flag to view just the first 5 lines? Well, there are a few ways to find out that I went over in the lecture. Many standard Unix commands and other programs have built-in help menus that we can access by providing a -h or a --help as the only argument. So let's try to access the help menu for head by running the following command in the terminal. So you guys can copy and paste this head space -h in your terminal. I'm going to clear my previous outputs. So head -h, you guys should all have seen, should see this output. Is there anyone that's not seeing that? Okay, good. So if we look at the output of the head -h command in the terminal window, I want you guys to answer the following question. Is -h a valid option for the head command, and how do you know? I'm going to put up another poll with this question in it for you guys to answer. Okay, so I just opened the poll so you guys can go ahead and answer that question. The question being, is -h a valid option for the head command, and how do you know? So go ahead and fill in that full question. You could do it based on the output that you got from running head -h. A few more of you guys to answer. Go ahead and type in your answer, even if it's a guess, that's okay. I am typing head -h, but nothing is populating. Yeah, it's because it's looking for the head command. Did you put a space in there, Tanisha? So
No.
did you get a command not found?
Yes.
Yeah, so it did the same thing when we tried to run a date-r without spaces, is the bash interpreter is looking for a command called head -h, and when it's not finding it, it's saying, yeah, this command doesn't exist in the system. And it's because it knows to stop after, once it reaches a space. So here it doesn't reach a space till after the -h, so we need to make sure that we have that space in there for it to know that it's a head command. And then you should get a message from head, the program that we're trying to run. So I think waiting on 2 more to answer the question, is -h a valid option for the head command, and how do you know? You can give me your best guess if you're unsure. Give it a few more seconds and then I'll close the poll. Go ahead and close that poll. And let's see these results. So I got, received another DASC error. Okay, Ty, go ahead and refresh So you can go ahead and just hit your refresh button on your browser, and then it should bring you back. You might have to select the small server option again, and then Ty, just put a message in the chat when you're back with us. So I'm just going to go over this answer.
And
Oh, go
we
ahead.
do have the on-demand servers ready now. So Ty, if you actually do get back to that first page where you're selecting the server type, pick one of the new options that say on demand in the name, and that'll prevent you from getting kicked off again.
Thanks, Lauren. I had to restart as well. Okay. Yeah, anyone who has to restart, Lauren, can you see that on your screen?
Let me disconnect and get there.
I'm gonna stop sharing and let Lauren share her screen. So that if you guys get disconnected, we've had our POC set up an on-demand system, which should be better about not kicking you off. So Lauren, you get that screen up, you can go ahead and share.
Okay, here we go. All right, so if you guys can see my screen, you can see that in addition to the original 3 servers that we were able to pick earlier today, our POC has put in 3 on-demand servers, which are supposed to be better about not kicking us off. So you can probably go ahead and select small server on demand if and when you get kicked off today. And then tomorrow morning, we'll all select this.
Thank you, Lauren. Okay. So I'm going to go ahead and share my screen again. So I just prompted you guys all to ask the question, or I should say answer the question, if -H is a viable option for the head command. And so I got a lot of the correct answer. So no, and most of you got the reason why. It tells you. So that's a nice thing about actually a lot of developers and how they write their programs, is that it will actually tell you if it's an error and why it is. So this we're seeing from the head command, it's telling us that it's an invalid option. And then it actually prompts us to try head -- help for more information. So it actually tells us what to do to learn more about the head command. I just want to make sure, Ty and Kanisha, were you guys able to restart your kernels? Back now. Awesome. And
Yes.
were you able to too? Yeah? Okay, awesome. Great. Okay, so now that we tried running that and -H didn't work, let's try to access the help menu for head again, but this time with the -- help. And again, this is just how the programmers wrote the program. So some of them will allow you to do just a -H. Some of them require the -- help. And so when we go ahead and run head -- help now, we should see an output that looks like this. Is there anyone not seeing that? No? Okay, great. So going back to our Jupyter Notebook now. So this allows you, let me go through this help menu. So this is similar to the help menu that we went over in the lecture, although a little bit different because in the lecture we used a program called man to pull up the help menu. Here we're actually running the program's help menu that was designed from the program. So it tells you here the usage. So this is where it tells you, similar to the synopsis that I went over in the lecture material. We see head option and then file. So here we have the head command. There's options that can be added. And now this time in the help menu, it says that file is optional, right? Because it's in brackets, but we know that's not true. So pulling things up with -- help can sometimes give you different information than in the manual that we looked at in the lecture. And so it also tells you in this help menu what the help command does. It prints the first 10 lines of each file to the standard output. And it tells you that if you have more than one file, proceed each with a header giving the file name. So you can put in more than one file in your head command. With no file, or when final is dash, it reads the standard input as in. So for those of you guys who are getting blank lines and you're just running head, it's because there was no input that you provided it. The head command also has a variety of optional options that you can add, and those are all listed here. And so what you have here is an option, and you'll notice that for some of these options, actually all of them, there's two ways that you can write it. For this one, for instance, which tells you if you want to print a certain number of bytes from each file, you can use either -C followed by the number, or you can use --bytes. Those two commands would do the same thing. And then similar, what we ran is this -n command, which is the number of lines. So we could have ran n, or we could have ran -- lines. So if you remember, we ran head -n5 of the example.txt file. Oops. Of the example.txt file and got the first 5 lines printed. We could have run the same thing from the help menu instead of -n. We could have used -- lines, and both of those options do the same thing. So again, it prints the first 5 lines. So this is another wonderful thing about coding, is that you never have to memorize what options are available in a command or what those options do, because you could simply just look at the help menu and take a look at the options that are available and pick and choose which options might be relevant for you. So that's a brief overview of how to run things on the command line. The other thing that we can do is, if you're unsure of what options are available for a tool, you can always just use an internet search engine to look for the help menu. So yeah, as mentioned previously, this is also written in Mike's tutorial, which again, all this is pulled from Mike's tutorial. The link to his full tutorial for Unix introduction is up here in the Jupyter Notebook. So I encourage you all to take a look and run through more of his tutorial on your own. But again, not about memorization. We can always pull up a help menu and identify what we need to for each program when we're coding or running commands. So now that we have gone through running things on the command line, any questions before we start running things within the actual Jupyter Notebooks? Okay, great. So you guys can, if you want to, X out of that tab. You can also leave it open if you want, but we don't need it anymore. So we're now on part 2 of running Unix commands in Jupyter Notebooks. And sorry, we have someone from Portugal, so should be leaving soon. And Elba, yeah, you could run through the notebook on your own. And when you have time in the morning, I'll have the recordings available if you want to follow the recordings along as you run through the notebooks on your own. But yeah, you should be able to run through it all the rest of the way through just by following the written text of the notebook or by listening to the recording of the lecture. And same goes for anyone. If there's any reason emergency comes up, you have to leave early. You guys should be able to run all of these on your own. Okay, so getting to part 2 here of the Unix intro, running Unix commands in Jupyter Notebook. So now that we know how to run commands and provide arguments in the terminal, we're going to learn how to do the same thing in a Jupyter Notebook. So as Lauren had mentioned, this Jupyter Notebook is running a Python kernel. Do you guys remember how we know? How do we know that this is running a Python notebook, a Python kernel? You guys just write in the chat like an area to look, or yeah, up in the top right, right. So we see up here in the top right that we're running a Python, and we're actually running the conda environment GL4U kernel right here. And just a reminder, as Lauren mentioned, if this ever freezes or you need a new kernel, you could click on here and select the kernel that you need from the drop-down menu. So if this happens, we'll go over it as many times as we need to. The other place that you can know is looking down here in the bottom left. So you see here that we also see Python conda environment GL4U, and this I would suggest looking down here when you're looking, because this gives you a little more information. It tells you that the kernel is idle. So if there was something wrong and it was like disconnected, this might say connected here. If you're running something, it'll say busy. So you get a little more information if you look down here. I'll tell you about which kernel it is. Now, this is a Python kernel, which means that the cell notebook is expecting commands written in the Python language. However, if you remember, I said that this is a Unix intro notebook, and Unix is a different language than Python. So we can actually convert commands from Python to Unix within the Jupyter Notebook environment by just adding an exclamation point in front of them without spaces. And so we're going to run that same head command on that same example.txt file. This time we're going to run it right in the notebook. So I think Lauren went over this when she was going over the notebook. In order to run these code blocks, we can just hit the play button here. You can also hold shift on your keyboard and press enter when your cursor's in the code block, and it'll run. So we can go ahead and press play. And it'll run this command, and you should see that we got this error here. Is there anyone not seeing that? Okay. So, and this is because we ran this command called head, but we didn't have anything in front of it. So because this is a Python kernel, Jupyter is expecting this command to be a Python command, but head isn't a Python command, it's a Unix command. And so this Jupyter Notebook is saying, wait a second, there must be some kind of syntax error because we don't know about a command called head in Python. And so what we need to do is add this exclamation point, which is a nice trick for Jupyter Notebooks with a Python kernel, is anytime you add an exclamation point at the start of your command, it'll tell Jupyter Notebook, even though I'm running in a Python kernel, this command is a Unix command, so please run this as a Unix command. And so now we're asking the computer to run the Unix command head, the same head command that we ran down the terminal just a little bit ago. So we can go ahead and press play in that code block. And you guys should all see something that looks very familiar. Is there anyone not seeing that? So this is, as Lauren brought up and went into a bit of detail with, this is one of the beauty of running things in Jupyter Notebook as opposed to on the terminal. Because on the terminal, you saw we kind of had to go back and forth. We were all kind of copy and pasting things in there. Whereas here on the notebook, we have this kind of set up for you, and it's written all around this nice descriptive language describing what's being done. And then the other cool thing is that the standard output is just right here, and now it's on there for as long as we want it on there, unless we clear our cell. And so with the exclamation point added, as you saw, the command runs correctly as if it were being run from a command line or a terminal. So we're going to use this conversion method in the Jupyter Notebooks that we're going to be running to process RNA sequence data, as well as for the rest of this notebook, in which we'll be running Unix commands within this Python kernel. So now I have a question here for you guys. I want you guys to run the head command again, which is set up for you in this next block, but this time I want you to add an option that we have gone over previously to the command to view the first 13 lines of the example.txt file. So I want you to go ahead and add that. You guys can write all inside these blocks. I want you to add the option that we would have to add to just to view the first 13 lines of the example.txt file. And when you do have it and it's working, I believe I also have this as a poll question. I want you to tell me the command that you ran that worked. Okay, so I just opened the poll. So once you guys play around and add that option in your command, I want you to copy and paste the command that you used to view the first 13 lines of the example.txt file and submit it into that poll that just popped up on your screen. And I'll wait till everyone's had a chance to do that before we go over. Yeah, you guys can scroll back up in the notebook to figure out what to do. You could use the help menu if you're unsure what option to add. So waiting for a few more to answer. Is everyone able to submit their answers? I don't have any trouble. It looks like I still have 2 more people that need to respond. Okay, I have 1 left, but I'm not sure if she had left or not. So I'm going to go ahead and close the poll. And we'll view your poll results. So I see a lot of right answers, some I don't know. Okay, so just going up again, if you're ever unsure, just kind of show you guys some things. So we can add a cell block. As Lauren mentioned, if you press the plus button at the top of your Jupyter Notebook in the toolbar here, you can add a block, and the default is to be a code block. And so similar to what we did on the terminal, if you're like, okay, well, I'm not sure which option I need to tell it how many lines, you can add a code block. So you guys can all go ahead and do that with me. And then type in your head command. Again, we put an exclamation point at the beginning because we're running this. We want to tell Jupyter Notebook that we want to run a Unix command, even though this is a Python kernel. So that's why we have that exclamation point at the beginning. And then we have our head command. And then if you guys remember from before, we use --help to view the head help menu, just like we did in the terminal. And then we can go ahead and run this. You can either press the play button here, or you can hold Shift Enter on your keyboard. And we'll get our help menu up. And so if you're unsure what option to add to view the first 13 lines, you can go and take a look at the help menu, which has now been outputted here, right in the Jupyter Notebook. And then you can kind of look through, how do I say that? Sorry about that. You can look through these optional arguments that can be added. And if you notice, as you read through all of them, there's this option -n, and which tells the program to print the first however many numbers you provide it of lines instead of the first 10. So that means that we can use this option -n followed by a number to tell head how many lines of the file I want it to publish, or I want it to print out. And so going back to my head code block here of the example.txt, so now I just want to add that option into the code. And how we know where to add it in the command, you can look at the usage part of the help menu. So it wants you to write head, a space, followed by any options you want, and then another space, and have your file that you want to view be the last thing that you put in the command. So that means that -n option to print a specific number of lines, in our case 13, I'm going to want to add right after the head command before example.txt. So I'm going to do -n, a space, the number that I want to view, which is 13, another space. So now this is saying I'm running this head command, this Unix head command. I'm using a -n option. That value for -n is going to be the next thing that comes after the next space, which is 13. And then I'm going to have another space, and I want to run head looking at the first 13 lines of this input file called example.txt. So I think about half of you gave the -n13, so that's absolutely right. And again, if you were unsure what option to add, you could just look it up in the help menu and read through the options, which is what we did here to know it's the -n13 being the number of lines we want to view from this file example.txt. And I'm going to go ahead and run it. Okay, so TIAS, is the exclamation point specific for Unix to Python, or could the same option be used between other languages? So this is actually for Jupyter specifically. So the Jupyter Notebook environment, when it's running a Python kernel, it expects all of the commands to be written in the Python language. But Jupyter has this nice trick that they embedded within the program. So that way, whenever you run, if you want to run a Unix command in a Python kernel, if you add an exclamation point before the command you want to run, before the Unix command, it'll tell Jupyter that I actually want to run a Unix command and not a Python command. So didn't put a space between the n and 13, and it still worked. Oh, that is pretty cool. Yeah. Sometimes, again, depending on how the program is written, it's good to keep to the standard syntax because you'll be less likely to run into issues. But it is true that there are some programs, like what Mark noticed is for this program, he didn't actually have to add a space here. and was still able to view the right thing. So it didn't require a space between the option N and the value for N that you wanted to run. So that's just how this program was written, is that it allows it to accept it with or without the space. That's not going to be the case for all tools, but for sometimes it'll have different things. Like you'll also notice that some commands are the same commands in Python as they are in Unix, so you won't need the exclamation point. So yeah, so that's true. And feel free to play around with things. Okay, so that's looking at the head command. I think we're about 2 minutes away from the break here. Yeah, so I asked you if it works. So the next command we're gonna do, we'll run through this pwd command and then get into our next 20-minute break. Any other questions about the head command or how to find things within help menus of tools? Okay, great. So we're going to move on to the pwd command. So this we talked about in the lecture. So if you want to list a command but not allow the command, this is kind of a note that I have in here. As you noticed here, we kind of printed out this help menu for head, which takes up a lot of space in the notebook. So if you kind of don't feel like scrolling up or down or just don't want to view that, and you'll notice that in our other notebooks, especially when we're viewing some of the output files for RNA-seq data, it'll be a lot. And so we can kind of just add a hashtag in front of any line in a code block. And now the system thinks that it's a comment and it's not executable. And so once you add that hashtag, you can rerun this line and nothing will be printed out because it's not running anything because it thinks that it's just a comment and not a command. So just a note there, if that's the case for anything that you run, if you don't want that output to be there anymore, you could just add a hashtag in front of it and rerun the cell and it'll go away. The other thing you can do is if you click on the standard output, so in this case, this is the output for the head help menu. You see this bar right here on the left, you can click on it and it'll hide that output. And then if you want to expand it again, you can either click on these 3 dots or click on the column to the left and expand it. So you could do that if you ever want to. So there's just a note about that. That does bring us to 1:30, and I do want to be respectful of our break time. So we are going to take a 20-minute break right now. And then when we come back, we will hopefully finish up the Unix intro notebook. So I'll let you guys go ahead and take your 20-minute break. And please be back here by 1:50 p.m. Pacific time.